All right, welcome to the solutions video for the series circuit problems, episode 903. It's been a long series. So I want to take a second. If you've started this already and you're just stuck, excellent. We'll work through the rest of it. If you haven't started it yet and you're ready to start, let's do it. If you're almost finished and you just want to check your answers, awesome too. All right, so I want to take a second and work through the series circuit practice problems here. So I'm going to share, which one is it? It is this one, I believe. Cool. So worksheet, series circuit practice problems. Drop that at the top. I'm going to use purple. Okay, so a couple things to think about here as we're going through. And actually, I'm going to add to this a little bit because I think we could use a couple more things. First, there are a couple parts of Ohm's law that will really help us out here. So I'm going to put a couple of the Ohm's law equations up at the top. V is equal to I times R. R is equal to V divided by I. And I is equal to V divided by R. We may have to use any one of these three equations as we're kind of going along here. Pretty sure. All right, so just a quick synopsis up at the top of some of the things that we said when we took the notes on series circuit. So current in every part of the circuit is the same. Current in a series circuit is the same everywhere. Voltage supplied by the battery is the blank voltage of the circuit, and the voltage drops across each resistor. Okay, so is the total voltage of the circuit, and the voltage drops across each resistor, add to the total voltage. So if we take the voltage over each component, they say resistor. We've been using light bulbs. They're the same thing. I'll talk about that in a second. But they add to the total resistance or total voltage. And to calculate the total resistance, all we have to do is add up what we're working with here. All right, so that's where we're working at. Like I said, we might use some of these Ohm's law equations, but we need to know that current is the same everywhere. Voltage supplied by the battery is the total voltage, and voltage across each resistor adds to the total voltage. And we need to know that to calculate resistance, all we have to do is add up those resistances. So here is our circuit. All right, and we have our first circuit. A couple things to think about here that we might not have seen. First, these little squiggly lines here. All right, what the hell are those? So people don't always like to draw light bulbs for everything. We've been using light bulbs as resistors, right? The things that provide resistance. But it's kind of a pain to draw light bulbs all the time. And one of the things that we might have noticed in our circuit exploration activity on current is the resistance of light bulbs don't always stay the same, but we'll talk about that later. So these little squiggly lines are essentially just light bulbs. All right, they're a different way to draw light bulbs. They're just a more general way of drawing them. So you can think about them as light bulbs, but they're resistors. They're things that resist current. So anything that resists current, right? You can represent it more generally as a squiggly line. We were being very specific and drawing light bulbs. So these resistors, they are the light bulbs of the circuit. This 90 volts right here, right? That's over top of our dashed line. That tells us what the battery voltage is. So this right here is the battery voltage. It's kind of like the voltmeter that we were using, right? Where we took the little screen that looked like this and it had a little needle on it, right? And we touched it to both sides of the battery and it read what was going on, right? That's essentially what they're doing for us. They're saying, okay, the voltage of this circuit, voltage of this circuit is 90 amps or 90 volts. All right, so that's like a little voltmeter that's measuring the voltage of the battery. We could also have it over different components. Like if you look down here, this is measuring the voltage over this resistor, right? We clip on to both sides of the light bulb and it tells us what the voltage of that light bulb is. So this is a voltmeter, and this little guy that says 5, just a little bubble in the circuit, that's like reading the current. All right, so these things are reading voltage. The things that's part of the circuit, those are reading current. So we have current here and we have current there, as we're kind of going along there. So just some nomenclature things, some schematic, I guess, things to consider here. So that's what we got going on. And then in each of these cases, it's asking us for, in the first one, it asks us for 6 things. It wants to know the total resistance. It wants to know the total current. It wants to know the current through resistor 1. So I1 means what's the current up here. I2, what's the current down here. And what's the voltage used by resistor 1 and what's the voltage used by resistor 2. So we want to find out a couple things. Now, the resistance in this one is probably the easiest thing to find because we know to calculate total resistance, all we have to do is add. Well, this is 10 and this is 20. 10 plus 20 is 30. That one's easy. All right, it gives us those 2 resistances. All we have to do is add them to get the total resistance. To get the total current, we have to do a little calculation, all right, because we're looking for current. Now, we know total resistance, right? That's right here. We also know that the voltage supplied by the battery is the total voltage. So this is the total voltage. So I have total resistance, I have total voltage. If I want to find total current, I have to use one of my Ohm's law equations. All right, so if I want to find current, total current would be total voltage divided by total resistance. All right, if we take those and we divide them, we can get the total resistance or total current. So total current is going to equal total voltage divided by total resistance. And we have each of those, right? We know voltage is 90. We know resistance is 30. So 90 divided by 30 will give us 3 amps. Current is 3 amps because actually I should probably write that out. 90 divided by 30. 90 being the battery voltage, the total voltage, 30 being the total resistance. We take 90 divided by 30, we get 3. I1 and I2, kind of a trick question, but like an easy trick question because we said the one thing right here, the current in every part of the circuit is the same. So if we know the current is 3 amps and the current in the circuit is the same everywhere, what's the current in the resistor 1 and the resistor 2? Has to be 3 amps. It cannot be anything else, right? In a series circuit, all these numbers are the same. We could actually probably go ahead and any place where we already know the current, like in this 3rd problem and this 4th problem, 5 amps means current's 5 everywhere. 5 amps means current's 5 everywhere. All right, just something we know. But once we know the current, right, the current everywhere, when we want to find the voltage being used, now we have to use another equation because voltage is current times resistance. So if we come down here, I want to know voltage 1 and voltage 2, and voltage is current times resistance. Well, I know the current everywhere is 3, right? 3 through 1 and 3 through 2. And I know what the resistances are. R1 is 10, R2 is 20. So 3, which is the current here, I'll write this, I1 is 3, and I2 is 3. If we want to find voltage, voltage is I times R. So 10 times 3, 30 volts. 20 times 3, 60 volts. And we could check that because we know that the voltage drops across each resistor adds to the total voltage. So 30 plus 60 has to be the total voltage. Total voltage is the battery voltage. 30 plus 60 is 90. So that checks out. All right, so we're doing a little circuit analysis here, right? We're looking at these circuits and we're seeing if we can figure some things out based on resistance, current, and voltage. All right, so there's that one. If we go over to the second one, and again, these are just light bulbs. We could draw in light bulbs if we want. We could leave them as squiggles, whatever is easier for us. You probably just leave them as squiggles. But I want you to know that these are the light bulbs, right? They're the same things. Total resistance. All we have to do is add up the resistances. 6 plus 14 plus 10, 20 plus 10, another 30. We get 30 ohms again. To figure out current, we know total voltage, right? This over here, this is VT, right? Because the battery voltage is the total voltage. So we have total voltage is 60. We have total resistance is 30. Ohm's law says total current is going to be voltage divided by resistance, right? That's right up here. Current is voltage divided by resistance. So voltage is 60. That's right here. Resistance is 30. That's right there. 60 divided by 30 is 2. So current, total current through the circuit. And actually, like I said, I should probably write this out. 60 divided by 30 is 2. All right, so our total current is 2 amps. Once we have the total current, we know the current everywhere. So current I1 doesn't even matter. I don't even care that it's I1 or I2 or whatever. Anything that says I is 2 now, right? It's a series circuit, so anything that's talking about current, anything that has an I has to be 2 because current is, where does it say that? The same, it's right there. It's a little bit too high to see, but current's the same everywhere. And then right now that I know I is 2 and I is 2 and I is 2, right? All of those are 2 amps. Well, I know Ohm's law says voltage is current times resistance. So we come down here, voltage 1, voltage 2, voltage 3. Well, I have resistances, I have currents. V equals I times R. And I'm not going to write these all out, but 6 times 2 is 12. 14 times 2 is 28. And 10 times 2 is 20. And we can double check that because if we add all these together, we have to get 60 because the voltage over the components equals the voltage of the battery. So 12 plus 28 is 40, and then 40 plus another 20 is 60. So that checks out. We get our total current, there's total resistance. That gives us our total current because we know the total battery voltage. And then we can just put in the currents everywhere and multiply to get our voltages. All right, so there's that one. All right, let's check something else here. So this one doesn't ask us for everything. This one asks for a little bit less, but we know that the current is 5 amps, right? This is reading 5 amps. So current everywhere has to be 5. Doesn't even matter. I don't even care what resistor I'm talking about. This could be talking about R1. This could be talking about I2. This could be talking about I total. Doesn't matter. It tells us a current. That's the current everywhere. So the current through every part of the circuit is 5 amps. These ones are a little bit trickier to figure out, but we'll puzzle through it. I want to know the voltage over 1. What's the voltage over 1? So there's actually 2 ways to do this. First, we know the current is 5, right? We can see current right there. We can see resistance. 5 times 10, 50, right? That's Ohm's law. V is equal to I times R. If the current is 5 here, then the current here, I1 equals 5, right? I2 equals 5. Current's 5 everywhere. So 5 times 10 equals 50. That'll give us the voltage. Another way to do it, we know that this resistor, this bulb is using 25 volts. We know the total is 75. So what's left over for R1? If this one's using 25, the total is 75. Well, the difference between 25 and 75 is 50. So there's 50 left over. All right, so 50 has to be used by that resistor, right? The battery is producing 75 and this one's only using 25 of it. This one has to use the other 50. All right, so that's another way to puzzle through that. And then the last part, we want to find the resistance of resistor 2. Well, we know the voltage of resistor 2 and we know the current of resistor 2. So this is another Ohm's law. R2 equals V2 over I2. That's right here. R equals V over I. So voltage divided by resistance, we know the voltage is 25 divided by current is 5, and 25 divided by 5 is 5 ohms. All right, so we get 5 ohms for the resistance there. Another Ohm's law problem. All right, so there's that. here, we want to know the voltages of each part of the circuit. And we know that the current is 5 amps. So current up here, I1, 5 amps. Current over here, I2, 5 amps. Current through every part of the circuit, even the current through the battery, 5 amps. It's 5 amps everywhere. And now that we know the current, we know voltage is current times resistance. It should be pretty easy to find the voltages. 5 times 5 for V1 gives us 25. 5 times 15 for V2. That one's a little bit harder. 15 times 5. Oof. 75? Let me guess 75. Because that's a nice number. 15 times 4 is 60. And then another 15. Yeah, 75. So it's 75. So V1 and V2, 25 and 75. And then the total voltage is really easy because we know that the voltage drops across the resistor adds to the total voltage. So if our voltage drops to 25 and 75, 25 plus 75 is 100. So the battery voltage is 100 volts. All right. So these ones are kind of like puzzles. These circuit problems are kind of like puzzles. We kind of have to piece things together. We have to use a little bit of Ohm's law, right? V equals IR, I equals R over, or V over R, R equals V over I. So these 3 equations, and then also some knowledge about circuits where the current is the same everywhere, voltage adds to the total voltage, and resistance is added to the total resistance. So we're using a couple different things here. This one we have 3 resistances, 5, 3, and 2. 5 plus 3 plus 2 is 10. We get the total resistance really easy. We're going back to almost like the first problem, right? Where we have total resistance. We also have total voltage over here, right? Because battery voltage is total voltage. And if we're looking for total current, current equals voltage divided by resistance. So if the voltage is 20 and the resistance is 10, current has to be 2. And once I know that the current is 2 amps, it's 2 amps everywhere. So the current through here, I1, 2. Current through here, I2, 2. Current through here, I3, 2. Right? Current through every part of the circuit has to be 2 because we calculated the total current to be 2. And then it becomes really easy because we're looking for voltages 1, 2, and 3. Voltage is just current times resistance. That's Ohm's law again. So 5 times 2, 3 times 2, and 2 times 2. 5 times 2 is 10. 3 times 2 is 6. And 2 times 2 is 4. And 10 plus 6 plus 4 is 20. That checks out. Our voltage components add to the total voltage. Easy. Last one. All right, let's check this one out a little bit. This one's probably the hardest because it's the last one. We know voltage over R3. We know voltage over R2, but we don't know what R2 is. We don't know anything about R1, and we know the voltage of the battery. So we can actually figure out the voltage over R1, which is this one right here. We can figure out V1 just by knowing these voltages, right? If this one's 20 and this one's 10 and the total is 40, what's left over? 20 plus 10 is 30. This is 40. So there's got to be 10 left over. So the voltage of resistor 1, V1, has to be 10. That's nice and easy. Let's see. What else do we know? Well, we have 2 here, right? We have a voltage and we have a resistance. We know that current is voltage divided by resistance. So 20 divided by 10 will give us I3, and 20 divided by 10 is 2. And once we know the current, and this is a series circuit, current is the same everywhere. So this is also 2. So current here is 2, I1 equals 2, I2 equals 2, everything equals 2. Everything has a current of 2. So we got 2 amps for the current. We got 10 volts for the voltage over this guy. Now we can go ahead and solve. And actually, this is the same problem twice, but resistance is equal to voltage divided by current. That's the third version of Ohm's law. we have a voltage, 10 volts, we have a current is 2. And here again, we have voltage of 10 volts and a current of 2. 10 divided by 2 is 5 ohms and 5 ohms. Those ones are the same. They have the same voltage and they have the same current, so they have to have the same resistance too. So there's that, right? Little combination of Ohm's law and knowing what's going on in series circuits. All right, so there's a little, like I said, they're kind of like a puzzle where you have to kind of piece some stuff together. You have to use Ohm's law some places, you have to use what we know about circuits some places, but in the end, we can piece together everything that we need to. All right. If you've finished with this and you've got tons of time left, there is another worksheet about circuits. Do I have it right here? I think I do. Maybe I don't. It's called series circuit homework. Should say series circuit homework at the top. But we'll work through that one. I'll make another video, last video I'll make for today on the series homework problems, so that when you start those, you're able to kind of get some guidance if you need it. All right, so there is that. All right, I'm gonna stop that there. And